In this video, I'm going to review how we notate the end behavior of polynomials and how we can predict the end behavior of polynomials based on their leading coefficient and their degree. But first, let's talk about how we notate them. So any polynomial function will have a domain of all real numbers unless the domain is explicitly limited by the context or some other part of the problem. But assuming we're just working with a polynomial equation, it'll have a domain of all real numbers, which means it will go to infinity for x, and it will go to negative infinity for x. There's no limit on where we can go for the x. So we describe the end behavior by talking about what happens at negative infinity and what happens at positive infinity. So let's start with, let's say our polynomial looks like this, for instance. Our end behavior describes what happens as we go in this direction and what happens as we go in this direction. So on this polynomial, as x approaches negative infinity, as x gets really small, the polynomial is going down, right? It's going to negative infinity. So, and as x approaches positive infinity, as x gets really large, this polynomial is going up. So those are the two things we need to describe in order to describe our polynomial. For this one, we would say as x approaches negative infinity, so as we go to the left, the polynomial itself, p of x, is headed down. It's also headed to negative infinity. So that tells us what's happening on the left side of the graph. But we also need to describe the right side. So on the right side of the graph, we say as x is approaching positive infinity, as we go to the right, and then we look at what p of x is doing. As we go to the right, p of x is going up. So we would say as x approaches positive infinity, p of x approaches positive infinity. So that would be this particular example, but let's look at all of the possibilities that could happen with a polynomial. So a polynomial could either look like this, it could look like this, it could look like this, or it could look like this. So we essentially have four options. It can either go up both to the left and the right, down both to the left and the right, or one of each. So we essentially just need a way to describe those four different directions. So let's look at the left side first. If our polynomial is going up to the left, we would say as x approaches negative infinity, p of x approaches positive infinity. So this means that our polynomial is heading up to the left. As x is getting really small, really negative, our y values are increasing. The other option is as x approaches negative infinity, p of x could be decreasing and going to negative infinity as well. So if our graph is heading down to the left, we would say as x approaches negative infinity, p of x approaches negative infinity. On the right side of our graph, x is getting really large. So if the right side of our graph is headed up, we would say as x approaches positive infinity, p of x approaches positive infinity. So as the x values get really large, the y values are also getting really large. Or the other alternative is, as we head to the right, as the x values approach positive infinity, then p of x might be going down. So these are our four options. We're going to have one option on the left, one option on the right, and we just choose whichever one matches our graph. So as an example, let's say we have these four graphs. Sorry, let me get this organized. Copy, paste. All right, so here are four polynomials. Let's say one of them looks like this. One of them looks like this. One of them looks like this. And one of them looks like this. So for our first option, the upper left, we would say to the left, as x is going to the left, as x is approaching negative infinity, p of x is going up. It's going up to the left. So p of x approaches positive infinity. That describes the left side. And then to describe the right side, we would say as x approaches positive infinity, p of x is also going up on the right side. So as x approaches negative infinity, p of x is going to positive infinity, and as x approaches positive infinity, p of x is also going to positive infinity. On this second one over here, we would say as x approaches negative infinity, so on the left side, p of x is going down. So p of x is also approaching negative infinity. So that says over here, as x is going to negative infinity, p of x is going to negative infinity. Versus on the right side, over here, as x approaches positive infinity, p of x is going up. So p of x is approaching positive infinity as well. Down below in the lower left, p of x is going down both on the left and the right. So we would say as x approaches negative infinity, p of x approaches negative infinity. So as x goes to the left, the graph is going down. And then same thing on the right, as x approaches positive infinity. So as x goes to the right, p of x is still going down. So p of x is approaching negative infinity. And then our final option, we have as x approaches negative infinity. So on the left side of this graph, it is headed up. So as x approaches negative infinity, p of x is approaching infinity. While on the right side, as x approaches positive infinity, p of x is going down. So p of x is approaching negative infinity. So for any shape of polynomial, you want to have two end behavior statements. One of them describes the left, and one of them describes the right. Okay. That being said, beyond just describing the end behavior, we can predict the end behavior just by looking at two important parts of the equation. So, if our polynomial is written in standard form, then we know that this is our leading coefficient, whatever is in front of the variable with the highest degree, and our degree is the greatest exponent. The leading coefficient and the degree are going to tell us the end behavior of the polynomial. So once again, we have 4 options. So let's start with let's assume that first our leading coefficient is positive and our degree, I'll make that purple so it matches. Let's say we have a positive leading coefficient and an even degree. So let's say the degree is an even number and the leading coefficient is positive, something like 5x to the power of 10. The degree is 10, so that's even. The leading coefficient is 5, so that's positive. So if we have a positive leading coefficient and an even degree, then our polynomial is going to look like this. As x goes to negative infinity, p of x goes to infinity, and as x goes to infinity, p of x also goes to infinity. So if we have an even degree and a leading coefficient that is positive, both sides of our graph are going to head up. If we have an even degree and our leading coefficient is negative, then this is just going to flip upside down. So instead of both of them facing up, both of them are going to face down. So if we have an even degree and a leading coefficient that's negative, let's say as an example, this was 5x to the 10th. This might be negative 5x to the 10th. It's still even, but it has a negative leading coefficient. That's going to flip it upside down, a reflection over the x-axis. So those are our options if the degree is even. If the degree is odd, then the end behavior on the left and the right side will not match. So if the degree is odd and our leading coefficient is positive, let's say, for instance, we have 5x to the 7th. Now my degree is odd, but I still have a positive leading coefficient. Then p of x is going to approach negative infinity as x approaches negative infinity, but it's going to approach positive infinity on the right side. And then just like with the upper row, if I have something like negative 5x to the 7th, if I have an odd degree, but a negative leading coefficient, this is going to flip upside down. It's going to reflect over the x-axis like this. So I can use my end behavior notation to describe these 4 options, but the leading coefficient and the degree will tell me the overall shape of the end behavior of my polynomial.